Okay, so we reached to part 4 and now we're almost done, but we have one last thing to clean up, which was the concept of operations on functions. And I know we've kind of done it. I just feel like we didn't talk about everything. Just be with me. So we decided, well, we recognized that f of x and g of x and h of x and all kinds of things of x or even of other variables is a really convenient way to talk about functions. So in a case, I could have f of x is equal to 3x squared plus 2 and g of x is equal to 1 over x, something like that. I don't know, 1 over x plus 5, whatever. So I can have two functions and I can ask you very simple things like f of 2, and you know to plug 2 into this equation to figure out what the value of the function would be at 2. And we've done that and that makes sense. And just for kicks and giggles, we'll write down that that answer is 14 here. And if I were to say g of negative 1/2, we can know that this answer would be negative 2, plugging negative 1/2 in there, reciprocal, blah, 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 so forth and so on. So we've got that. We know how to evaluate functions. But when we talk about operations on functions, and we've discussed many of them, we talked about the fact that I can create a new function, f of x plus g of x. And basically that means take the two functions, add them together as they are, and you create robo function, big function. No, you create another function. We could subtract them and I can change the order, g of x minus f of x. And again, I create a different and more interesting and more involved function, and that'll be 3x squared minus 2. That negative is distributed. I could also multiply my function. So g of x times, look at the dot that I just wrote, f of x, and that little solid dot is going to mean multiplication, and of course it means 3x squared plus 2 over 1x, or over x. And so that's if I like kind of combine things. When I have something like this, when I have basically a function over a function, in a sense that's a function over a function, or I could even write it in more of a division type of way, I can do that. When I have what looks like a function over a function, I refer to that as a rational function. So that's just some language that we hadn't talked about before. If I have 1 over x and then 3x squared plus 2, could you simplify this? Hopefully you said, of course I can. It's 1 over 3x to the third power plus 2x. Yeah, sort of, kind of making sense. So when you add, subtract, multiply, or divide, you can simplify and create this new function. And so the new function has properties of its own. You'd have to consider the domain and the range. Another way of combining functions, addition, that was weird. Addition, subtraction, multiplication, division, we did all of that. We can also do composition, and we have discussed that. But the one thing that I didn't say that I wanted to make sure that I said was the way that we see composition of functions. So sometimes you might see it straightforward as g of f of x, and we know to handle whatever's going on with f of x and plug that result into g of x, and then we'll get our answer. And in this case, we would have g of f of x would be 1 over 3x squared plus 2. F of g of x, again, a different way to compose the function, would yield 3 over x squared plus 2. Follow along with me. Let me know if this isn't making sense, because I would love to talk to you about it a little bit more. And so this is a way to compose functions. Sometimes in some textbooks, you might see g of f of x written as g circle f of x. All right? Or you might see f of g of x with this circle. Please don't confuse it with the multiplication, which is going to be a solid smaller dot. And so they mean the same thing. And finally, we talked about inverse functions, where if g of x and f of x were inverse functions, which they're clearly not here, but if g of x and f of x were inverse functions, when I take the composition in both directions, I would get x as a result. And so with that in mind, that's all I wanted to say. Aren't you glad that this is the shortest video ever after watching the other ones? Guys, have a good one. I'm going to give you an assignment. I'll send you an assignment via email. Take it easy. Bye-bye.